Hey, everybody. Welcome to another JetBrains live stream. We're really excited to have you today. As you can see, there are multiple colleagues here. I'll introduce them soon, but before I do that, let's do a little bit of housekeeping like we always do. I see there are a lot of folks in the chat currently, so remember, this is an interactive live stream. So if you're watching us live right now, remember to ask questions in the chat and we'll get to them as best we can. So on that note, there's always the question that gets asked: is this live stream being recorded right now? Of course it is. It's on YouTube. So if you want to head out, step out for a second, pause, come back, you can always watch this, rewatch this live stream at any point in time. And yeah, it'll be available on JetBrains TV. So be sure to like, subscribe, hit that notification bell. On that note, I'm going to introduce my colleagues. First of all, the esteemed Dr. Jodie Burchell. Hi, Jodie. Thanks for joining us today.
Hi.
Next, we have Matt Ellis, Sir Matt Ellis. I think he was knighted by the Queen. So, Matt, thanks for joining us today. And then we have Maarten the Machine Balial. Maarten, thanks for joining us. I'm excited about today's live stream. So here we go. You guys ready?
Let's do
Absolutely.
All right.
Let's do this.
So to give folks some context, this live stream, we build tools here at JetBrains, and we always want to build the best tools. So part of building the best tools is having conversations with our community. We recently did a survey and we reached out to about 100 game devs. Those game devs are multi-engine users, and they work on team sizes ranging from a single developer up to companies that have up to 5,000 individuals. So we're talking from indie the whole way up to AAA game devs. And this was kind of the main engine breakdown across those 100 devs. We have 66% of them using Unity game engine, 39% using Unreal, 22% were actually writing their own C++ bespoke game engines. And in the top 4, we have Godot at 18%. So just to kind of give you an understanding of kind of the context of these questions. So folks, colleagues, have you ever experimented with these game engines? Which ones are your favorites? Chat, also this question applies to you.
Been mostly playing with Unity so far, but thanks Khalid for doing a small work in progress game that we might be using internally at JetBrains in Godot. I've really had some fun this morning, so I only started doing some Godot this morning, but it's a fun one as well. So looking forward to play more with that one.
Yeah, and I see the chat is really like in the Godot Unity camp, and I see a little Unreal. Someone asks, is C++ a game engine? It is if you want it to be. So on that note, I also want to say throughout this live stream, we're going to be giving away 3 one-year AI Assistant subscriptions. So pay attention, get your screenshot tools ready, or hit the pause button and write these down. First person to get these subscription codes can redeem them at jetbrains.com/store, and you get a full year of AI Assistant. So on that note, here's the first one. So there you go. I'll also paste it in the chat. All right, let's move on. So I'm going to pass it on to Jodie. She is a data scientist by profession, and she's going to explain how large language models work, and you'll learn something. That's kind of cool. So Jodie, stage is yours.
Thank you. And just sort of as an explanation of why we're including this at this point, when we were setting up this live stream, we were talking about actually using large language models and our own AI assistant for game coding. And Khalid was saying that you think that the coding assistant for Godot is a lot less polished than, say, for Unreal and Unity. So I'm going to give an explanation as to why. I promise it's not going to be too technical. We're going to keep this really high level. So let's jump into the slide. I know I said this isn't going to be too technical. I promise I'm not going through this diagram. So to give kind of a short explanation of what the model's underlying AI coding assistants or AI kind of text assistants, they're all based on a type of model called a large language model. I think we all know this at this point. And as you might guess by the name, large language models are designed to do a variety of natural language tasks. They are language models, it's in the name. So these can include things like generating text, of course, but doing things like summarizing text or answering questions. And they're based on a type of neural net. You can see that on the screen here, called a transformer model. I think a lot of you would have heard about this at this point. And the reason that we're kind of seeing large language models now, that are so polished and work so well, sometimes we'll get into when they don't work so well, is because this transformer architecture, unlike previous models for processing text, tends to scale really well. So it can take in a lot of text in the context window. I think you would have seen that if you played around with it. But it can also train on a lot more text. So it means the model can learn a lot more than previous models. So this, of course, leads to the second ingredient in the success of large language models. So generally, when we're talking about large language models, there's a lot of them, but the ones we're talking about are generative large language models. And they're based on a specific part of the transformer architecture called the decoder. So what these decoder-based models do is they're exposed to millions or billions of example sentences. And for each sentence, they're asked to predict the next word in a sentence. And what's so special about this is it allows you to basically build really big training sets, because you don't need to manually label this. You can basically just split a sentence at a point, and you can use the first part of the sentence as an input, and you can use the next word as the thing the model has to predict, the target. So just to kind of briefly sort of show you in a little diagram how this model training works. You might have, say, a model exposed to this sentence, the cat sat on me, and it has to guess the next word. And initially, when these models start getting trained, they're basically guessing at random. This is what happens when you train neural nets. But as it gets exposed to more and more data, it can start making much more accurate predictions. And then what we've ended up with over time is these models that, when they're exposed to some sort of input, can guess the probability of the next word with a pretty high degree of accuracy, depending on the data, and we'll get to that in a second. So, with this one, we input I have, and the model can predict the next word after that, and the next word after that, and so on and so forth. So this brings us to the data that these models have been trained on. And I told you, these models are trained on really huge amounts of text data. So if we're talking about a lot of data, what we're talking about is potentially something that's very expensive to obtain. So pretty much all of these large foundational models that you might have heard of, things like GPT 3.5, GPT-4, Mistral, Llama, they're actually trained on publicly available data sets. And they're getting a little cagey about the data that they're trained on, because they're all starting to use the same data. So they're getting, trying to get competitive advantage by being, a little sneaky about what they're actually using. But earlier models were a bit more transparent about this. So we know that the sources can include things like Common Crawl. This is a huge dump of the most frequently linked pages on the web. It's about 10 petabytes when it's unfiltered, but normally filtering is applied to it. Includes open source repos from GitHub. It includes Wikipedia. It includes public domain books from Project Gutenberg. Include more scientific texts like Archive and PubMed, and Stack Exchange questions and answers. So basically, what you kind of see is potentially a big variance in the amount of data that talks about different topics. So in the case of Godot, for example, potentially there's not enough training data for the models to learn very well. And I work in Python primarily. I know, I'm a bit of a odd duck here in this setting, but I've seen this myself. Like, Python has a lot of training data. So normally AI coding assistants work really well with Python. But if, say, I'm working with a newer framework, it will often start hallucinating, or it won't be able to come up with coherent answers. So yeah, this is just a little primer on LLMs and why they work the way they do. I'm going to be sort of going back and forth with Khaled to explain a bit more about this area, but this was, just the foundations.
Yeah, it's interesting too, like what you said about Godot specifically. There's also like a versioning issue with data sets, right? So from Godot 3 to Godot 4, the language changed. So like the training set might have more Godot 3 data, but when you go to like generate Godot 4 syntax, there just isn't enough out there. Just recently released, right? So, but
Mhm.
Unreal and Unity are just going to have larger code bases and samples and communities out there. So, I find that kind of interesting. So, um, yeah. Okay. Let's move to the next slide. I think there's a new code. So anyone who wants to grab this in chat, good luck to folks. And we'll go from there. So try to get that. Good luck, folks, for real. I think we're going to move on to another question here from the survey. Which types of generative AI tools do you use for game development? So again, remember, we asked 100 game devs what tools they're using. This isn't our opinion. This is what people are actually using out there. So 64% said they're using code generation, which makes a lot of sense. We are a game dev company that works with coding tools. So I feel like that would be pretty high. 31% use image generation. 50% are using it to generate text. I imagine this is like a script or NPC dialogue. And 13% say they're not using any AI tools at all. So, Matt, Maarten, what do you folks make of these results?
A number of things. I think the more interesting one here, I think, is that a lot of people seem to be using the tools for code and text generation, which is usually, at least in terms of codes, very often it's boilerplates or it's just algorithms or whatever. And yes, there's some creativity in there, but very often it's something that you can more or less generate based on a prompt that you might give. Whereas images, for example, feel like they are more of a creative thing. Where level design or just a generic feeling of what the game should look like and feel like is something that should really be in the hands of the creative people on the team and is not easily outsourced, so to speak, to an AI assistant, for example.
Mhm. Matt, what are your
Yeah,
thoughts?
it's pretty much the same kind of thing there. Yeah, I mean, generative AI tools are very, very good for text-based stuff, and it's great to be able to take some of the boilerplate away from when you're working with code. There's a lot of things IDEs can do already with boilerplate. Auto completion is a great thing, but you can actually then do much more then with sort of being able to generate code. And work with an AI assistant that can actually work at a higher level than an IDE can traditionally work at.
Mm-hmm. Yep. I see someone in the chat said boo for image generation. And I really get that sentiment, right? Like from a creative perspective, when you're making a game, you're trying to create an experience. So you want to put care and thought behind that kind of stuff. So for me, I kind of understand where that individual is coming from. So, here's another slide from Jodie. Jodie, do you want to explain this particular slide?
Yeah, and kind of on the image generation stuff, in my next section, I'm going to be talking a bit more about creativity and LLMs and why we're kind of not at the point where LLMs really can take over from creative professions. And I'll kind of explain why. But yeah, one thing I also want to say is I have worked in natural language processing for a big chunk of my career, and I find the current discussions around LLMs a bit disheartening because they're specific tools for specific things. And it feels a bit, I don't know, especially at the beginning of last year when people were saying, these jobs are going to be outsourced, that job's going to be outsourced. It wasn't really a very healthy conversation. And I hope what we can have here today is a lot more nuance and discussion. So yeah, I'd like to hear your comments in the chat about what you kind of think of the models. We're definitely not pro team 100%. This is going to replace jobs or anything like that. So yeah, hopefully I can get more into the nuances and where they're helpful and where they're not. Mm-hmm. So that leads to a bigger discussion about AI and what it actually means. So this is a term that I think over the last 2 years has almost lost all sense. Like it's become more of a marketing term than a scientific term. AI is obviously a field. It's been a field since the 50s or so. Really what AI is any kind of machine or artificial system that can mimic human cognitive abilities. And it doesn't mean AGI, like artificial general intelligence. It doesn't mean, it has to do everything. It can just automate something. So we can see on the first kind of image there, the natural language processing one, this is sentiment analysis. It's being able to automatically categorize someone's feelings or opinions about something. So this is actually AI. So AI, as we're talking about at the moment, is generative models. This is a really small subset of stuff that exists in AI. And the current generative models came from 3 fields. They came from natural language processing, which is just concerned with being able to automate tasks with text. They came from computer vision, which is a field concerned with processing images. So we can see in this image, this is image segmentation. It's being able to automatically identify objects in images. It can be useful for, say, classifying what that image is about. And they also came from signal processing. So this is a huge field. It's very broad, but it's basically concerned with analyzing signals, including audio and voice. So generative AI is really just, as I said, the latest models in these fields. And to be honest, these are still a pretty small part of the actual useful application of these fields. Generative AI doesn't have a huge amount of actual use cases. And I think something that drives this home is one of the big things that people were buzzing about in the AI space, I think last week or the week before, was Meta's latest model that they released, which is called SAM2, which is segment anything. And it's segmenting, a object identification model for video and for pictures. So this is a very different thing to generative AI, but this is, a model that is very cutting edge, and people are still working on these sort of problems, probably much more than generative AI in a lot of ways. So when we talk about AI in our live stream, we're not going to be talking about computer vision. We're not going to be talking about signal processing. We're talking about something very specific. We're talking about the application of large language models to coding problems. And the reason that we at JetBrains think that this is a good application is because basically this plays to the strengths of LLMs. As I told you, they're text prediction machines, and they're really good at doing things like generating code if you teach them how to do it, or translating, say, between natural language, like something like a pull request, and code. And the reason I think code is a good use case is because these large language models have a tendency to hallucinate, to come up with false results. So they need someone to check them. And with development, you have that. You have someone who is going to be able to see whether the results make sense. You're going to have a compiler or an interpreter that can check for you. But, other kind of things like design, I'm not entirely convinced can be outsourced in the same sort of way. So yeah, this is just a sort of grounding about where we're going to be coming from, and kind of trying to flesh out AI a bit more, because I know AI in game development is a slightly provocative title. This is specifically what we're going to be talking about today.
Okay. Yeah, I mean, I think I'm in the same camp as you as well. It's like the design and the care, and we're going to see that later in kind of what our pool of game devs have been saying, like in terms of how they feel and where they're going to use LLMs. But before we get to that, I think we're going to pass it on to Maarten, who's going to do a Unity and AI Assistant demo to kind of show us what he's learned using our AI Assistant with his journey in Unity game dev. So take it away, Maarten.
Absolutely good idea. So for folks who are doing Unity, you will be very familiar with the Unity editor here. I'm not going to really go into Unity specifics, but I do want to go into AI Assistant specifics in Rider, which is our game dev IDE for Unity, Unreal, Godot, whatever you're using there. So if you're interested in that one, by the way, go to jetbrains.com/gamedev to learn more. You can find a trial there. Give it a go if you haven't yet. It's really good at what it does, even without the AI. All right. If you have JetBrains installed and you have opened a Unity or Unreal or Godot project, you can start working with the AI Assistant using the tool window that we have there. And this is one of the main entry points into the AI assistant that we have in Rider. So what it allows you to do is essentially ask any type of question around code, around your project, and so on. So it could be something very generic like suggest me some game mechanics. And you will get back some game mechanics that you might be using. If you have no inspiration for what game to build, you will see a couple of things. The nice thing about that is that you have this context in AI Assistant where based on the mechanics you get back here, you can ask follow-up questions and maybe go into what would be a good mechanic for a racing game. And there you would also get back results. If you have an existing project, you can also ask questions about the project itself, like what was my latest commit? Can you summarize the latest changes that I did and things like that? So AI Assistant will give you back some information there. Now, I already saw in the chat that someone was concerned about data being sent to the server. Right now, Rider does not send your entire project or every one of your assets to the server. You can actually see what's being sent to the server and what context is being shared. If you click the kebab menu here and say dump chats, you can dump it somewhere on your desktop. So let's go with my desktop and then see what is being sent over the wire. So essentially, it's mostly context about the fact that I'm working with a Unity project. I'm using the Unity editor and I'm using the built-in render pipeline in Unity, which is great, because now AI Assistant will always know that I'm in this context, so it won't give me back GD script codes. And imagine that I'm using Godot, for example, it knows that I'm in a Unity project in this case. So keep that in mind if you want to inspect what's going over the wire. Now, AI Assistant is really good for learning, and maybe I already know a lot about Unity and how to build games and so on in Unity, but maybe I want to learn a little bit about how I can, for example, extend the editor that is there. So what I could do is say, how do I create an editor window, for example? And again, based on that context of being in a Unity game and so on, you will see that you get back Unity codes where you can read through how to do things, but also what the script could look like. Now, also here, I can ask follow-up questions. And if that's a long response there. If everything came back, I can actually ask follow-up questions and maybe work with those. So let's say, can you explain how to add a list to it? Again, follow-up question, and the AI assistant will come back with a follow-up based on the previous answer and give me an example of how I could do a list in an editor window in Unity, for example. Now, what is really cool, and let's wait for it to generate. Another nice and long example. I'm going to stop there. I might read through everything, but maybe I just want to explore and see if this thing works. I have no idea how UI works in Unity Editor, but maybe I can just create a new file from here. So from this snippet, I can say create new file. I can give that thing a name. So let's say custom editor window. And if I now go back into the Unity editor, you will see that under window, custom editor window, there should be a new editor window with a list where I can add strings, save list, load list, etc. So from here, even if I have no idea how to do this thing, I can use AI Assistant to learn about all of those things and see how I can improve my workflow there. Now, let's ramp it up a little bit. And when I first started my Unity journey, and that's not too long ago, so last year somewhere, I knew about game objects, so I knew that you could add empty game objects, for example. I knew that you could add scripts, let's say a game controller, and then work with those. But I had no idea how in code I could do something like adding new game objects to the window. I did not know about camera rotation and so on, doing that programmatically. The good thing is that I also learned to use AI Assistant for that. Now, chat is one entry point into AI Assistant. There's another entry point, which is in the code editor. So if in the code editor, you press Alt-Enter, AI actions, you will see that you can explain code, suggest refactorings, find problems, start a new chat, write documentation, and so on. And I can generate codes. Now, what I want to do in this demo is essentially create a really quick game with a player and an enemy that walk on a grid of Lego bricks. I already downloaded some assets from the asset store, so that's ready. but I'm going to use AI Assistant because I have no idea how to code this. Well, by now I have, but I just want to share the learning journey that I went through here. So I can generate codes. If you do that, you can inline ask AI to generate codes. I already copied the prompt that I'm going to use here. And essentially, I'm going to generate a 5x5 grid on the X and Z axis with a grid element prefab that I will define later on and color those grid elements randomly red, blue, green, yellow, or gray. Going with that, AI Assistant will come back with a diff view inline in the editor that I have and tell me that, of course, I will need a game object that will contain the prefab here. It will, in the start method, generate the grid, and then the grid itself will use an array of colors alternatingly and randomly select one of those. No idea if this is going to work. And frankly, in my learning exercise, I might not even care yet. So I'm just going to accept this code and go with that. And just to make it look a little bit nicer, I'm going to reformat things. All right. This code looks complex. I have no idea what this would do. So I just generated the codes. If I want to learn what's going on here, I can make a selection of just a couple of lines of code or select this entire methods, go with Alt-Enter again, AI actions, and explain codes. This will jump into the chat, and of course now a is being sent, but I will get a good explanation of what the snippet of code is doing and what is going on. So again, a lot of text, but it's really cool in that you get some of the, not only the how, like how you would create a position or how you would position a grid element and so on, but there's also a lot of whys typically in the result there. So this is really great for learning how to work with those things. Now, I'm going to keep it at that and wire up a couple of other things a little bit later, but let's continue building this game. So what I want to do is add a couple of new game objects that I want to define. I want to have a player prefab. I want to have an enemy prefab. And ideally later on, because I know I want to be able to programmatically work with the objects that I'm creating, I'm also going to add a private game object player. That was the wrong completion there. I'm also going to copy this one and make that one the enemy. All right, back to AI. You saw that previously I used Alt-Enter and then AI actions to generate codes. There's also a nice thing in that you can prompt using comments inside of your code. So here, what I could do is say, create player from player prefab at the 3x3 position in the grid. Wait for completion to kick in from AI Assistant, and then I will get some code that initializes the player prefab there. Now, this distance is not defined, so let's maybe try that again and see how it will work. We might get a different suggestion there. Okay, no, distance. I am going to imagine that, or I'm going to think based on the code here that this distance is going to be the result there. So let's extract that one into a variable that we can use elsewhere in code as well. Interesting thing, when you use AI, you might get different results every single time you generate something. So again, this demo is slightly scripted, but also I'm playing by what I get back from AI assistants. All right, let's add our enemy as well. Create enemy from enemy prefab and place it at the edge of the grid. Let's go with that. And let's see what happens. All right. I have no idea if this is gonna work. So let's see if we can find out. Let's go back into Unity, go to our main game object there. And first of all, hook up all of the prefabs that we have there. So I have my grid element, which is gonna be a 2x2 brick. My player is going to be a green blocky figure, and I have an enemy prefab as well, which is going to be a red blocky figure. And let's go with that. If everything went well, without even having to think too much about the code, I should have a grid with different colors, a player, and an enemy there. This is awesome. It just works. Right, let's spice it up a little bit. First of all, that view that I had there was not ideal. So what I would love to see is that the camera is on top of the grid that we have there. So let's move the camera so that it shows the entire grid from the top. It's really tedious watching me type here live, but there we go. We see that the main camera is accessed. The position is replaced so that it's in the center of the grid that we have. And we have this 5x5 grids, and half of it will be 2.5 times the distance between the grid elements. So that looks good. And then we're going to rotate it 90 degrees so it's top down. So this looks good, even looking at the code after this. So thank you, AI Assistant, for that. All right. We will check that in a bit. The next thing in the game is typically adding controls. So what I want to do is in the update method, which is invoked on every single frame in Unity, what I want to do is make sure that my player can move around. So what I'm going to do here is paste another prompt in codes. And that prompt is move the player to the grid element in front of it. When the arrow up key is pressed, do not move out of the grid. Completion I get back is not working. So let's try that again. No idea what this is valid grid position is going to be. But let's forget that for a while. All right. Again, I say that every single time we run this demo, it looks different. So the only thing I'm going to do here is, well, let's maybe keep it. Let's see where we end up. Next thing we can do is say add the other directions. And what's cool is that even if you don't know what the next prompt should be, by doing something like this, AI Assistant will figure out, okay, this is too vague, so I'm going to include a little bit more codes. And if I now add the other directions, you will see that it's actually creating new prompts for me. So move the player to the grid element to the right of it. When the arrow right key is pressed, do not move out of the grid. Same thing with left. And same thing with arrow down. So I guess now the only thing left is to implement this is valid grid position. And why not give it a go? So I'm going to create a method here in Rider. Let's go with a Boolean backward position. You will see when you generate a new method that AI Assistant also gives you these context actions in the gutter, which you can invoke using Alt-Enter or just click it. And you can say, implement this with AI. So let's see what comes back. Because there might be explanation needed here, AI Assistant is going to add this into the chat window, and it might give you back much more code than you need here. But if you read through that, let's hope we get an is valid grid position that actually works for this particular one. So I'm going to stop here because we already have the methods. This private bool is valid grid position looks good. If you're lucky and this would be generated as a single snippet for just that method, you could just dump it into the editor. But in this case, I have to copy paste and paste it in. All right. My distance is there. My boundary is 5x5 index 0. So this looks good. And checking for the position also looks good. So the only thing left is to actually give it a try in Unity. Let's go back into Unity. Again, we rotated the camera. So ideally, we see a top-down view. Yes. And if I now use the arrow keys, my blocky dude is actually moving around and I'm not able to leave the boundaries of the grid. Pretty cool. All right. One more thing that I want to do just to have some gameplay there is that the enemy should be able to catch the player that we have. So what I'm going to do here is say, start a coroutine that moves the enemy towards the player. Also wait for completion to come up. Now, coroutines in Unity are a way to have an essentially a bunch of tasks running every single time that there's a clock tick in the game, where you can do something that is not really part of the rendering pipeline that you would have in the update method that is there. I know this is there, but I have no idea how to implement what is in there. So the only thing I'm going to do here is, again, create a new methods, return an IEnumerator, that much I gathered from the documentation, and then have AI Assistant implement everything here. It's giving me an explanation of what is happening. Again, in the interest of time and this demo and so on, I'm not going to read through and just go with the results. So insert snippet at carrots. It's going to update every second. okay, this is going to be very slow, but let's give it a try. And maybe one more thing that I want to do is when the enemy catches the player, reset the player position. Let's go with that as well. Get some completion from AI Assistant and go with that. And again, let's give it a try. Back into Unity. Back into play mode, which, by the way, you can also do from Rider if you just want to look at what's going on in the codes. My enemy is moving agonizingly slow because of that 1 second delay, but it is now working. And when it catches my player position is reset to the initial position. So without even having to think too much, I've written a small game with some interesting gameplay. It's very easy. I should still add scoring and so on. Code-wise, it's maybe not the best. But with this, I'm actually really happy that I built something that I can use. And the next thing that I could do to learn about things is essentially go into every single block of code that is in there, or just go with everything and ask AI assistants to explain this code, or maybe suggest refactorings or where I could improve this code and so on. So I created all of this. I'm really happy and excited that I have everything. And now I can go back into the explanation, essentially repeat the entire thing, read into what's going on, why things are happening, etc. So really cool. And with that, I think I covered most of the learning things by just building a small game in Unity. Back to you, Khalid.
Okay. Yeah, that was kind of awesome. You know, it's like, especially for folks just maybe wanting to get something working. I think what you showed was kind of an amazing experience from a development standpoint. But this kind of segues into the next interesting question from the survey. You know, you built out a lot of boilerplate. Your game was very code focused. But as everybody knows who uses one of these engines, there's typically a mix of different things that go into a game, whether it's assets, whether you're building a component, whether you're building prefabs and things like that. So a question we actually ended up asking a lot of the game devs in this survey is, what work would you delegate to AI? As Jodie says, it's kind of like a vague concept, but AI in general, and what would you not delegate to it? So generally, a lot of folks said tedious and repetitive tasks, and they would not delegate detailed and important tasks. So there's a lot of nuance, and it's open to interpretation here. And what are some of these tedious and repetitive tasks? Well, top task users would most likely delegate performance investigations, game engine optimizations, testing, screen or scene prototyping, better known as whiteboxing or sketching, writing side quests, which I find interesting, and also non-playable character design. So those strange characters in the background that you can never interact with, those kind of things. So Maarten, Matt, Jodie, what do you folks think about these results?
They
I
seem
think it's
sensible to me. Yeah. Yeah. Go ahead, Matt.
Yeah, let's just talk over each other. This is good. No, I think these are quite sensible as well, Maarten. There we are. We're finished. No, so my view is that you know, these are a great thing for using large language models and so on for, because it's a great way of explaining code and understanding code. We spend a lot of our time as developers actually reading code, and we're having to read code that that somebody else has written, or that we wrote 6 months ago and have completely forgotten what it does. You know, we can write documentation, but that can get out of date. So we spend a lot of time reading and trying to understand code and summarize code, and that's exactly what LLMs are really good at, summarizing things. And so if you're looking at a complex block of code and you want to try and understand A, what it does, then it's a great thing for explaining it. But B, summarize it so that you can understand what's going on and look for common errors. You know, the LLM can look for common patterns, you know, like, I don't know, nested loops, which are doing far too much work when you could have a lookup instead. And you can get the LLM to suggest refactorings for you, look for problems in the code. And these are a great way then of, you know, doing these kinds of investigations. Testing is a good one as well because it's good for generating all those scenarios. It can give you, it might not be able to generate the whole test for you. It might not be able to give you an exact test, but it's going to generate you a file full of scenarios much faster than you can type it. So take that boilerplate away, get somebody to give you a skeleton, an outline of what it is that you want to do, and make use of this kind of thing. So I'm a big fan of all of those kind of top things there to get the LLM, the AI assistant, to take the boilerplate away from you.
Mm-hmm. Yeah, I totally agree. The one thing that's actually surprising on here is writing side quests. For me as a gamer, I always find some of the side quests to actually be more fun than mainline quests. So I would think like even those side quests are important, but it's kind of surprising. I don't know. Non-playable character design makes a lot of sense. Yeah.
Again, with the side quests, I mean, you can use that to help you generate stuff. This is still a tool. It's not going to take over the thing. It can help you generate a side quest. If you're concentrating on the main quest itself, it's like, oh, I need a side quest. I can't think of any ideas because I'm too focused on this main thing. Get the LLM to suggest a couple of things, which you can then use as a catalyst to then generate the thing that you want to do, to write the thing yourself, or to use it to fill in the gaps when you've generated the outline. There's ways of getting it to help you rather than actually do it for you.
Yeah. Go ahead, Jodie. I see there's a thought bubbling in your brain.
I actually was just thinking about those side quests in The Witcher 3. There was one where you have to like help an old lady find her fry pan, and I have never forgotten that side quest. If there's a game that took care and love with every part of the game, it was that one.
Yeah. So, folks, if you want Jodie to play her game, just put a frying pan in it. That's how you get her.
I will find your frying pans, all of them.
Maarten, do you have any thoughts on this slide, or should we move on to the next one?
I was just going to echo what Matt was saying. Basically, on most of those things, I think performance investigations is a really interesting one, because not only is it good at summarizing things, but very often if an LLM finds in the text or the code that you have that there's something really sticking out like a sore thumb, it will find the issues there. So it will summarize, but also if there's something that is out of the ordinary, so to speak, typically you will get a result where that thing sticks out.
Yeah. Well, speaking of sticking out, I think Matt convinced me that using LLMs to write side quests is a good idea, because you can at least get an LLM to vet that the characters are working within a particular motivation that you've already set in the main quest. So it's a good tool to kind of double check that, hey, I wrote a side quest. Are these characters or are their motivations in line with what they're doing in the main quest? Because you don't want your hero to all of a sudden push an old lady off a cliff, right? Like that would be bad. So let's talk about tasks not likely to be delegated. So developers feel like programming the core gameplay, so the fun of the game, is something that they would likely not delegate out. Backend programming. So here, think about multiplayer, think about accessing a third-party service or anything like that, or database. That is something that's probably a little too critical for a lot of game devs to delegate out. The main quest, we talked a lot about quests. So focusing on and writing the main quest is something a lot of folks would not delegate. Designing the UI and UX. So think of the HUD, think of the buttons, the experience there. Definitely something that folks are a little weary about delegating out. And then ultimately the lore and story creation of the game and the game world. So anything surprising here for you folks?
No, especially things like...
I think it boils down... Oh yeah, go ahead.
No, you go, man. You go.
I think it boils down to one of those initial questions where all of the creative aspects come up here as the results, and it is something that people find important in their game to make it personal, to really set the overall look and feel of the game, how things work, fine tune all of that to make it their game and not just something that is AI generated, so to speak.
Mm-hmm. Yep.
Yeah.
Go ahead, Jodie. No, go ahead.
I was going to say as well, like, it kind of comes back to the motivation for making a game, right? Like I've never made one, but I imagine you're inspired by the story you want to tell and the world you want to create. So if you're coming in already with those ideas, this is the fun part. Like this is the thing you're making, your creative kind of work.
Yeah, and I think for me, like some of the most engaging experiences that I've had with games have come from indie devs trying to tell a particular story. So, like an Undertale really stands out, and that was like a very important message that game was trying to tell. I won't spoil it, but definitely check out Undertale. It was a very cool game. So, on that note, Jodie, you have a particular slide. We talked about what people feel they would delegate or not delegate, but maybe why are people having those feelings?
Yeah, and it's so interesting for me to see the way that what people delegate lines up with what the models are good at. Like it makes sense, right? So intuitively, people are testing this out for themselves and seeing this. So again, I'm going to labor this. LLMs are language models, so they're good at language tasks. We've seen with Maarten's demo, they're very good at text generation, and they're good at solving problems with code, and they're good at other text things. Like you ask it a question, it's good at answering the questions. It's good at summarizing. It's good at other things that are outside of the scope of what you might use a generative model for, like summarization and classification. LLMs are notoriously bad at math. This has been shown again and again. There are ways of getting around this. So if you use, say, GPT-4, it can access a Python interpreter to run some math code. But by itself, these models are really bad at running, doing math. They're bad at generating things like random sequences because they're probabilistic models. We've seen that. They're bad at knowing recent information unless they have access to a search engine, which again, GPT-4 does. And they're bad at giving consistently accurate answers or truthful answers. They tend to hallucinate, as we've talked about. So there's kind of like limitations to what you can apply these models for. And in particular, if they were going to replace skilled jobs in game development, which I don't think they're going to anytime soon. I really want to make this clear. There are two things they would really need to get their head around. One is creativity and the other is logic. And I found the nicest study that came out last month about creativity. So basically a group of researchers, they got a group of participants and they divided them in two. They asked them to come up with as many creative ideas about a new story they wanted to write in an amount of time. One group could use an LLM, the other couldn't. And what they found is in terms of the number and diversity of ideas, the group that were allowed to use the LLM came up with more ideas. They were more creative in the amount of time. But that was as individuals. When you compared the group, like the pool of answers that they'd come up with, their answers all tended to overlap because these models are basically averaging the training data they see. So it seems like everyone's converging on the same ideas. So it's really interesting because, yes, this can serve as a really nice seed, but you still need to be a creative person and put your own personal touch on those ideas. Otherwise, they're just going to be the same ideas that everyone else is using. The other is logic, and we were actually talking about this in our internal channel at Slack. Some of you might have seen a little experiment that was done last year where someone typed into, I think it was ChatGPT, I can't remember, who is Tom Cruise's mother? And it correctly gave the answer Mary Lee Pfeiffer. And then they asked, who is the son of Mary Lee Pfeiffer? So if this model is using logic, right, it has that information. It should tell you Tom Cruise. But at the time, the model couldn't actually answer it. I did notice with 4.0 it can answer it. I suspect this is some manual jigging behind the scenes, but this is my own suspicion. But like it's well known, anyone who understands natural language processing knows that these models are pretty weak with logic. And until they can kind of do those complex multi-step reasoning kind of chains that we can do as humans, you know, there's going to be severe limitations to how complex like the applications that these models can make are. So yeah, I think this is why we're seeing this kind of use for boilerplate or tedious tasks, because this is the hard limit of the models and they're great for it. I use it all the time when I'm doing data science work, but this is the niche the models have at the moment.
Yeah, it's funny you say boilerplate and tedious tasks. One of my tedious tasks I really like to do is converting a human list, so like a bulleted list, into a format that maybe like my application or game can consume. And that's been super helpful, or taking that list and converting it into HTML that I can kind of display somewhere. So those tasks have been like real huge time savers for me. Like I could sit there and type HTML, but man, who wants to do that?
Ain't no one got time for that.
Khalid, here's a secret for you. I mentioned that I started Godot just yesterday, essentially. And so the game we're building is a game to learn shortcuts in the IDEs that we have. And there's our web team has a big XML file with all of the actions and what the shortcuts are on Mac, on Linux, and Windows, and so on. But that XML file is like 35,000 lines of XML. And I essentially asked the AI assistant to do just that. Interprets this XML, and if this is the input, this is how I want the output formatted, and I got a nice result that I could use. So you might think I spent 4 hours on this, but I actually didn't.
Oh, you cheated me, Maarten. I wanted you to do work. No, it's fine. Well, on that note, let's get to Matt, because Matt is our Unreal expert here at JetBrains. So we're gonna have him. Hey, take the compliment, Matt. You are my expert.
I'll take the compliment. I nearly forgot to unmute myself there. Yeah, so I'm going to talk about a few things again with the AI assistant. We're going to talk a little bit about Unreal, but also Unity and Godot. Because one of the things that we kind of really haven't covered with the AI assistant is the fact that we've got context. And that's one of the key things with the AI assistant that we have is the ability to provide context to the AI assistant itself and to the LLMs behind the scene there. So one of the really powerful things is that Rider will look at what your project is, decide that it's a C# project or a C++, that you're using Unity, what version of Unity you're using, what version of Unreal or Godot or GD script, and pass that all up to the LLM with every request there. So there's a lot of sort of interaction with the IDE there. There's a lot of using the information that the IDE itself has got. And I'll show a few things that show this, and then also kind of show you some of the nice features for using the AI assistant as well. So one of the first ones we wanted to show was kind of about some of the upskilling ideas of things. So understanding things and learning and understanding stuff like that. So we can use Alt-Enter to get our AI actions prompt up, and we can use this explain code, select what it is, and get an explanation of what's going on there. So it's a nice way of sort of summarizing the code and explaining what it is. If that's all just a bit much, you can just say, well, summarize it, and we should hopefully get a much briefer explanation of what's going on, rather than it having to sort of document everything. It's not that much briefer, but there we go. Other things we can do here as well, if I bring up AI actions, is our suggest refactorings. So look at the code there, see what might be wrong, and suggest some refactorings. More useful when you've got like a massive block of code. Really useful when you're prototyping. You just want to type, get to where you want to go, and then you're going to come back and clean the code up. You can get the AI assistant to suggest refactorings for you. You can ask it to find problems, and again, you can choose which scope it's going to be, whether it's just this particular method or the class. Hopefully this method is fairly simple and there's not going to be too much going on there. There's a couple of things it's going to suggest there. Log message formatting, okay, it's not inconsistent, but it's all fine. And useful things for it to sort of be able to do and suggest. One of the other really nice things you can do, though, is that the AI assistant has some deep hooks inside the IDE itself. So we don't send your whole project up to the LLM. We don't kind of give you all that information. But what we do provide is a set of functions that the LLM can ask the IDE to do. So it can do text search, symbol search, all this kind of thing. It can make use of the indexes and things that the IDE has already built of your code. So I can say something like, where is it? Where is the title screen shown? And this is my simple Unity project I've got going on there. And what we can see here, what's the message it's going to tell us? It's shown by the method show title screen in this particular class, tower defense main menu, which is great. And it also can then find the usages of this code as well. Not terribly useful in this instance, just showing us that little snippet of code. We should have a link there which would take us to the actual position, but it's showing that we're actually doing a find usages from the IDE to find where that code is actually being used. And because we've got such great integration with Unity in Rider, we can actually show you where this method is being used inside the Unity scene as well. So we can see that this show title screen method is being called from the main menu Unity scene, and you can actually see then whereabout it's being used. It's being used on the back button for the level select button and the options button as well, and it tells us then how we can access it and go and find it. So it's a great way of being able to understand what your code is doing and learn how it's being used and really sort of upskill from that point of view. But it's not just sort of limited to the code as well. We've got sort of documentation. So I'm in Unity here. Well, I'm in Rider. I mean, I can just say, how do I rename a variable? If I could type variable. And we want to be able to use some of Rider's refactorings. And here we are. You can pull information from the refactoring, through the product documentation. And it tells us we can use the shortcut Shift F6 in my case, in the keyboard scheme I'm using, or you can right click and use refactor to rename it, enter the values and updates. So it gives me documentation for the product, which is nice. But because it knows it's a Unity game, I could do, well, how do I compile for Android? And that will then hopefully go off and tell us how to set up a Unity game to work with Android. Going to make sure we're installed there. You can go to the external tools. Yeah, we can use the build settings, select Android and switch platform. So it's telling us there, it's giving us the steps to be able to build an Android game out of our Unity package. If I swap over to an Unreal project here now, so I'm in C++ world, it again has the context that I'm in an Unreal project, and I can type, ask a question here as well. Let's say, how do I set a breakpoint? Where I breakpoint in a blueprint. And again, the AI assistant knows that we're talking about Unreal, and it gives me the steps there, open the blueprints, locate the node, and right click, and we're good to go. I can do the same thing in a Godot project as well. So I've got a GD script project going on here. Let's see, how do I check for collisions? Let's see if this works. And there we go. It understands that we're in Godot. It's given me some GD script information here, a bit of code snippet, and some useful data there. So again, it's a great way if you don't understand how something works. You could open a bunch of browser windows, open several tabs, read through, summarize it, or ask the AI assistant to do it for you. So that's very good, again, about summarizing information. Let's jump back to Unity here and with a new chat. We can kind of get it to help us while we're working as well. So upskilling, I saw some questions in the chat about shaders and generating code for shaders. I don't really know much about shaders. I've read a bunch of tutorials. I've watched a whole lot of YouTube stuff, but I don't really know where to start. The AI assistant is a great way to kind of kickstart those kinds of things there. So it can help me there. So I can get the AI to give me a starting point. So I could say something like, how do I create a water shader? And hopefully then it should give me an example of creating a shader in Unity. And it will create me an unlit shader there, rename it water shader, gives me the shader lab properties that we're going on. And if we have a look here, we've got a surface shader there, which is doing some stuff with trigonometry that, frankly, I haven't done since I was in school. But then it tells us how we can apply that, adjust the properties, and use it, which is great. So that's a nice way of being able to sort of learn how to do it. If I wanted to go into my code and actually create something, so let's create a new unlit shader, and let's call it black and white, because I want to try and create a shader that's going to make everything turn black and white. So let's go, I don't know, let's just have a bit of an empty sheet here and delete a bunch of this. And here we're going to ask it to generate us some code. And let's say create a shader that slowly desaturates. Let's do that. Desaturates. Have I spelled that right? Desaturates. Yeah. Over time. And again, now that the LLM should give me some useful information there. to be able to generate a boilerplate, which I'm working on there. So I've got a vertex, I've got a frag shader there, which looks like it might be doing something. Yeah, we've got the linear progression multiplying by a time factor, and so that could be a useful thing, although I'm not entirely sure about the update there. That looks like it might be a C# one. So let's try that one again and say, let's just say, is the update method correct? And we'll see what it comes up back with this time. And it looks like it's generated it again without that there. So we've got a double NCG, but that's going to be fairly easy enough. If I accept that, I could just easily delete that, and we could then use that as well. So it gives me a good way of sort of being able to find out what's going on. And in fact, if I wasn't quite sure what was going on there, I could select this code here. Let's see what I'm doing. New chat from selection, explain this method. And it's doing it again quite verbose, but it's explaining then what's going on. So it's a nice way of being able to help me learn to work with shaders and understand quite what's going on there, which is useful. Testing is also a good one. If we want to move on to something else, if we can have a look at generating a test. So I could create, well, let's go to Wave. Let's go to my spawn agent method again. And what I could do here is Alt-Enter, go to my AI actions, and let's do new chat using selection. I'll select that there, and it will be generate some Unity runtime tests for this method. And we see now that hopefully that we're going to be able to generate some tests. What's it doing there? So we can see it's adding our game object, giving it turn down, and spawning items correctly. In fact, let's go to a more interesting method here. Let's go to ballistics, ballistic projectile. And let's do it here, and we can do AI actions. Well, in fact, I can just go straight here. New chat, generate some runtime Unity tests for this method. That method right there, please. Let's try that one again. I should just be able to rerun, actually. Edit, rerun. And again, here now we can see that it's great at being able to generate some tests for us with a whole bunch of scenarios that we don't necessarily have to think of up front. The LLM is going to decide these scenarios for us, which we can then use to verify that that is the activity that we wanted to test, and make sure that everything is working as expected. Last couple of things I want to quickly show you. If I just jump back to Wave here, you can see, no, I want that. We can see we've got some documentation here. Let's just get rid of this. LLMs are great at explaining stuff and doing things and taking away some of the boilerplate. So we can use the Alt-Enter menu here to write documentation, and that will then just generate some documentation for us. Straight away there, it'll generate proper C# doc codes there, XML doc, and give us a summary and an explanation, and sort of format it all nicely for us as well. We can do a similar sort of thing for C++ and work around that too. Other useful things we can do for explaining stuff is if I go to my commit list here, I can see now that down here, Maarten has added an add day-night cycle commit, and I can double click and look at all the changes that have been made here and figure it out for myself, or I can just right click on this and I can do explain commit with AI Assistant. I can also find errors in a commit, which is a nice way if you're kind of trying to look through a bunch of commits and see if there's any problems going on there, you can do that. But if I explain the commit here, then we can see we get a nice summary of what's going on there. So instead of me having to look at all the different diff files that are going on there, I can just summarize this too. We can do the same thing for generating commit messages as well. If I can remember where I put that shader, black and white shader, where did that one live? That was in script tower defense level. In fact, why don't I just right click on that? Let's do git and add. And let's just unstage some of these things, so we don't need to worry about that. And then if I just do down here when I should be putting a commit message, we've got the AI Assistant button there, and I can actually sort of generate a summary of what's going on there. So we can actually see what's being changed. I don't have to think all the time about what the code is there, and I can then help my team out by working on code. We're also getting a little tooltip here to say that we can actually customize the prompt as well. So if I wanted to change how the prompt was being, how the code was being generated, I could do so there. And in fact, being able to change your prompts is also a very nice feature here too. So if we go back to our AI Assistant chat, I can use a little button down the bottom here, which might be a bit tricky to see, but there's a button there which says add your prompts. And my dev build doesn't work. I'm going to have to quickly swap to another version. Let's just jump over here. If I go to add your prompts there, we get the settings page here where I can create a new prompt, which I can say, what are we going to do? Let's do add logging to, let's say, dollar selection. There, so that's got called add logging to section. It's going to appear in the AI actions prompt. And now if I go here to compute velocity, I can then do Alt-Enter AI actions. And down the bottom here, we've got our new item, add logging to selection. We get to choose whether it's going to be the whole class or just this method, which I'll do. And it will then pop that into the chat and generate that for me. So this is really useful if you've got like a step that you want the AI assistant to do very frequently. You can create your own prompts and reuse those and work with it. And again, because it's in the chat, it's all really rather nice, because you could say, let's just say, where are we? Be less verbose. And it should then regenerate that with less logging going on there. We should be able to see it's using, hopefully, a few less features there. And I think really that's a brief overview of some of the more interesting features that the AI Assistant has got that can take away some of the boilerplate for you. It can help you learn. It can help you generate test cases. It can help you generate documentation, do the boilerplate type kind of thing there. It can also help you with custom prompts when you've got extra features that are going on there. So Khalid, I'm going to hand back to you.
All right. You know what's funny? You showed that Godot sample. Just yesterday, I was writing a car drifting game in Godot, and I literally didn't know how to make a car collide, and I spent like an hour just looking for collision detection. Yeah, I really should have. I should have just used the AI system. What was I thinking?
It's such. It is. I mean, it does change the way you work in places, because it is such a habit to be able to go to. You go to Google, start searching, open up a bunch of tabs, start reading, and do that kind of thing, when you can actually just ask it to summarize it for you.
Yeah. I will say though, like I did notice it was suggesting Godot 3 stuff instead of Godot 4.
Godot 3? Let's see what happens.
But it's Godot 3 and Godot 4 have like slight variations in the API, like the kinematic body. Yep. So there you go. So again, you still have to pay attention to what you're getting back. But yeah, this is correct now. So
I mean, sorry, just to say, that's a really important point though, is you do have to pay attention to what you get back. You know, this is a tool, this is a helper. You're still in charge. You're still the person building the game, writing the game. So don't just blindly trust these things. You know, make sure that it works. We say the same about the standard features in Rider as well. Don't just blindly go through and Alt-Enter and fix everything. Only fix the things that make sense to do.
Good point. Very good point.
You're in charge.
So on that note, I see a lot of chat is saying this stuff looks cool. People are like, the shader stuff is going to change my life. So on the last code is here. So good luck to the last individual here. Yeah, go for it. So let's kind of wind down with some of the last questions in our survey. We talked a lot about seeing what the context is, what information goes over the wire. I know a lot of people, especially in the game dev industry, there's a lot of NDAs, there's a lot of secrets. No one wants to kind of spoil their IP for anyone. So a big question typically is around, would you use a remotely managed AI service or feature? And this was kind of the breakdown. So 41% said yes, 30% absolutely not. They just don't trust a remote service. 21% are just kind of unsure what that means. Hopefully, for those folks, they're kind of seeing what a context is and what information does get sent over the wire. So maybe they can kind of make up their own mind. And I think it was odd that 8% are in this other camp. How I interpreted it was like basically it depends what the remote service is getting and who it is and what they're doing. What do you folks like? You folks are working with AI Assistant a lot. What are you hearing from the developer community when it comes to this question?
So yeah, I'll jump in first. This has been a concern since we first released this as a closed beta. And it's a fair concern because there are a lot of worries, as you said, that your IP could be stolen. So in terms of the agreements that we have with our providers, so we work with a number of third-party providers such as OpenAI and Google, and we're working on agreements with other providers. We're being very careful with the agreements we have with those providers. So we are not entering into any agreements where they can store data, use it for training. The only reason that they can ever use the data is to basically check for security. So check that this looks like an organic request and it's not that, you know, it's basically hijacking the API and using it by a bot. So it's a fair concern, but essentially we are well aware of it. And before we even started designing AI Assistant, this was something that was first and foremost in our minds.
Mm-hmm. That's really good to hear. Hopefully, folks understand that we take this stuff very, very seriously, and yeah, we want you to feel comfortable using our tools in general. So, Maarten, Matt, any other thoughts on this slide?
No, pretty much exactly what Jodie said. You know, we have entered agreements where we are paying attention to this, and we make it clear as well on the website and as part of using the AI assistant that there are data policies in place with the links to go and see those so you can view that. Just do want to add, however, that we also have full line completion available in the latest round of releases, which will give you the sort of code completion for just a single line. It's a much smaller specifically trained model which runs on your device. So it's not cloud-based at all, but it gives you code completion for a single line on your device. And I have to confess, as a personal preference, I like that more than the multi-line completion because it completes the thing I'm thinking of rather than necessarily making me stop and read a block of text to carry on. So as a personal preference, I like single line completion more than I do the multi-line completion. But the key thing to point out is that is part of the, it's all running on your device. And it's available for C#, C++, and then the other IDEs as well.
Mm-hmm. Yeah, and I will say too, to add to this, it's like the people who are just firmly in the no camp, like we do offer the ability to disable these plugins or uninstall them completely. So don't feel like we're trying to force this on you. But I do think like part of getting into development is evolving and trying things and seeing if they work for you. And also come back and try it again. This stuff is still evolving very quickly. So don't just discount it and never come back to it. Definitely keep an eye on this stuff. So definitely good at it.
Can I quickly jump in for the other camp? Because that's also an interesting one.
Yeah.
You mentioned services or cloud, but what if there is a service that sits somewhere in between? That is a service that runs in your own data center, runs your own models, and so on. I think a lot of people are interested in that. And I just want to mention that in IDE services, that's another tool we have or a service that we have. We are considering and looking at exploring that avenue as well, where you can host your own models in your own Kubernetes cluster and so on. So if you're interested in that, also do reach out because we are looking for people in the other camp.
Okay, cool. That's really good to hear. So let's move on to the next question. So we asked people, what are your biggest difficulties today with AI in game development? And as no surprise, some of the things that take a lot of time, prompt writing and specificity. You saw Matt and Maarten, they're pros at writing prompts. You kind of have to have an imagination and really think about what you want and be explicit. Sometimes our JetBrains tools feel very, you know, very smart about the suggestions they make, especially when they're dealing with statically typed languages. But with LLMs, you do have to be very specific about what you want and to give it enough context. And I think that's still something a lot of folks are maybe learning and upskilling at.
I want to just
yeah.
jump in on that one as well, because I
Yeah.
find that the prompt writing, for me, with the kinds of prompts I've been writing, it feels a very similar skill to how to Google efficiently. It doesn't feel like it's a million miles away from that. If you can find things on Google, then you'll be able to sort the prompt out as you go. And the key thing as well is that the chat can be refined. You can make follow-up questions. And that is pretty much a killer feature, which you can't do in Google. You can't refine a Google search. You have to start again.
Yeah. And I think you showed that with the Godot sample, right? So maybe there's something we need to do to make sure to separate and pass in Godot 3 versus Godot 4, but you were able to refine that even after that information came back. So I think that's a really, really good point. The one that's kind of really evolved from the beginning of when LLMs were kind of introduced into the dev space to where they are now is kind of the current and latest information in these models. Jodie, do you have any information specifically about like, like how current is information? Like you were saying earlier that some of these model providers are a little cagey about what's in the data sets, but how do you feel about the data set problem in this space?
Yeah, so part of the problem is with the really, really, really big models, they're so expensive to train that the knowledge base tends to get locked. So I know with GPT-4, which is still a state-of-the-art model, no, it's not. Sorry, it has been superseded by 4.0. But up until a few months ago, it was a state-of-the-art model. Its training base was 2 years old, 2.5 years old. So with the Claude models that we've just integrated into AI Assistant, they're a bit more recent. One thing that we're experimenting with, but sort of logistic problems with integrating it, is something called retrieval augmented generation. It's the idea that maybe potentially you can give the models access to even an internal knowledge base or some sort of documentation, things like that, and it can give more up-to-date answers. But the models are already very slow. This is actually one of the reasons we're relying on third-party providers. And adding an additional step where they have to do a lookup and then integrate that and then return an answer, it's hard to do in real time. And you saw how fast the AI assistant is. That's not an easy thing to make. So yeah, it's an ongoing problem with the use of the models, but there's definitely ways of doing it. It's just integrating it in a way that's fast enough is tricky.
Yeah, I mean, it definitely, again, it feels like this field is definitely evolving very fast. So it feels like it's a potential solvable problem, and we'll get to it. It's just a matter of probably when, I feel. So yeah, again, keep an eye on it. I think this stuff is very interesting. The other thing that's kind of been amazing to see in terms of its growth is really this context size limitation. Matt and Maarten showed that, with JetBrains AI Assistant, we have access to all these IDE features that can go find files, can build this context for you. And for the longest time, the limitation was how much data could we fit into a single context. That limitation seems to be kind of fading away very quickly. Jodie, do you have any more to add to like the techniques there with like tokenization and how they've been able to expand the size of these contexts?
Yeah, I know there's some tricks that are used. So say when you pass in, say you're doing a chat with ChatGPT or our AI assistant or whatever, like just a chat with an LLM. As you kind of pass more things into that chat, all of that actually is passing the context window. So remember I said that LLMs are really good at summarization? One of the tricks that they can use is summarizing that stuff on the fly and that helps compact the amount of tokens that are actually going in. So yeah, it's really cool, the kind of clever tricks that they're using to exploit the capabilities of LLMs.
Mm-hmm. Okay, cool. Maarten, Matt, anything else on this slide, or should we move on?
I'm good.
Yeah, let's move on.
You are good, Matt. You're the best.
Thanks, buddy.
Yeah, just to kind of start wrapping up this live stream, we want to kind of point you to one of our colleagues, Marco Beller. He has a channel called Marco Codes. He mainly focuses on Java, but he just recently did a really great YouTube video about prompt engineering and kind of how LLMs, especially in JetBrains AI Assistant, kind of work and how you can kind of get the most out of them. So definitely check that out. Go give him a like, subscribe. He always does great content around Java. And here, congratulations to the 3 folks who ended up getting those 1-year subscriptions. If you're not one of those folks, we want to thank you anyways. So here is a 1-month subscription to JetBrains AI Assistant. This should just work for everybody. So if you're interested in checking it out, if you like the demos that you saw today, here's a code for you. And yeah, thank you for joining us. If you want to learn more about what we do here, you can go to our official channels. Since this is a JetBrains, focused on game dev, Rider really is our premier game dev environment. So you can check out more about Rider at jetbrains.com/Rider. You can check out our .NET content over at blog.jetbrains.com/.NET. Follow us on our social media channels. If you want to learn more about AI Assistant specifically, which is available for all JetBrains IDEs, you can go to jetbrains.com/AI and follow us again on social media. Since everybody wants to be a YouTube star, I'm going to give one of our colleagues here the opportunity to beg you to follow us on YouTube. So who wants to do this? Who wants to do the honor here?
Let's all do it.
Right.
Everyone, if you're watching this stream, if you loved what we did here, give us a thumbs up. Come on, everyone, thumbs up. And if you really want to see other live streams that we do subscribe to our channel as well. Thank you.
Yep. Great job, Maarten. You're the best at this. Yeah, I want to just thank Jodie, Maarten, Matt, really the best people to do this kind of live stream with. And yeah, I want to thank you folks in the chat. This has been kind of an awesome thing to see with folks engaging. So that's why we do these live streams. We do it for you, and we really appreciate you. So on that note, thanks everybody. We'll catch you next time. Bye.
Thanks, everyone. Bye-bye. Thanks, Khalid.
Thank you. Bye.
Bye.